Our problem states a water park has approximately 500 visitors daily, each paying $25 for a ticket. For each $5 increase, the water park estimates it will lose 20 visitors. If the water park needs to bring in $18,750 per day to stay in business, what ticket price must be charged to produce this amount of revenue? Round your answer to the nearest tenth. First, we want to ask ourselves, what should x equal? Now, after reading this problem, we know that the new ticket price is equal to the old ticket price plus the number of ticket price increases times $5. We also know that the number of passengers that will pay the new fare is equal to 500 minus 20 times the number of $5 ticket price increases. So, if we let x equal the number of $5 ticket increases necessary to bring in $18,750 daily, we can rewrite the new ticket price equal to a numeric expression and the number of passengers that will pay the new fare equal to a numeric expression. So the numeric expression for the new ticket price equals the old ticket price, which is $25, plus the number of ticket price increases, which is our x, times $5. And the expression that can be written for the number of passengers that will pay the new fare is 500 minus 20 times the number of $5 ticket price increases, which is our x. Now we can form an equation that will help us solve this problem. We know that the new ticket price times the number of passengers that will pay the new price should equal our desired daily revenue. This means that 25 plus x times $5, that whole quantity, times 500 minus 20 times x should equal $18,750. After simplifying and rearranging this equation, I get 5x plus 25 all times negative 20x plus 500 equals 18,750. After FOILing this out, I get negative 100x squared plus 2,500x minus 500x plus 12,500 equal 18,750. Now I'm going to add or subtract everything from the left side over to the right side, so I'm left with 0 on the left side and 100x squared minus 2,000x plus 6,250 on the right side. To make these numbers a little bit easier to deal with, I'm going to divide both sides by 50. And I'm left with 0 equals 2x squared minus 40x plus 125. Now I know that I can use the quadratic formula to solve this equation. So I know that my a equals 2, my B equals negative 40, and my C equals 125. If I plug my A, B, and C into the quadratic formula, I get negative times negative 40 plus or minus the square root of negative 40 squared minus 4 times 2 times 125 all over 2 times 2. If I simplify this, I get 40 plus or minus the square root of 1600 minus 1000 all over 4. If I simplify this even more, I'm left with 40 plus or minus the square root of 600 all over 4. Now using my calculator to find the square root of 600 and rounding to the nearest tenth, I get 40 plus or minus about 24.5 all over 4. So this gives me the two values of 40 plus 24.5 over 4 and 40 minus 24.5 all over 4. Using my calculators and finding both of these values, I get that x is equal to about 16.1 after rounding to the nearest tenth, and x is equal to about 3.9. Now, we need to remember that our x value is equal to the number of $5 ticket increases necessary to bring in $18,750 daily. So our first x value of 16.1 means that there's a possibility of 16.1 $5 ticket increases necessary to bring in $18,750 daily. And our other x value means there's a possible 3.9 number of $5 ticket increases necessary to bring in $18,750 daily. So in order to find our possible new ticket price, we need to plug our x values into the new ticket price equation. So to do this, I get 25 plus 5 times 16.1, or 25 plus 5 times 3.9. After solving for this, I get a possible new ticket price of about $105.63, or a possible new ticket price of $44.38. We want to look at our possible new ticket prices and think what value seems realistic. It is probably not realistic to think that visitors are going to pay $105.63 for a ticket. So our best answer is $44.38.